So now let's discuss about part 3 of operators and decision constructs. So part 3.2 is equals versus equals, then dot equals, then string pull traps and wrapper comparison. So we have already discussed all these topics. Videos are available, you can have a look. So equals versus dot equals, the fundamental rule, right? This is a very important concept for the OCA exam, equality comparison. The rule is very simple, but many candidates forget it under exam pressure. For primitive types, the equals operator compares actual values. For example, int a equal to 5, int b equal to 5. Here a equals b evaluates to true because both variables store the same value. For objects, however, equals does not compare the content of the objects. Instead, it compares their references, meaning the memory addresses where the objects are stored. If you create two separate integer objects that both contain the value 5 and they are stored in different locations in memory, as a result, equals will return false, even though the values inside the objects are the same. To compare the actual content of the objects, you should use the dot equals method. This rule applies to all object types including integer, string and custom classes. In short, use equals for primitives to compare values, but use dot equals for objects when you want to compare their contents. Okay. Next, we are going to discuss string pool, same literal, same object. Okay, so Java has an optimization for strings known as the string pool. When you create a string using a literal such as string a is equal to hello within quotes, Java first checks whether the value hello already exists in the pool, string pool. If it does, then Java reuses the existing object instead of creating a new one. As a result, if you write string a equal to hello and string b equal to hello, then both variables reference the same object in the pool. So a equals b will evaluate to true. However, when you create a string using a new string hello, the string pool is totally bypassed. Java creates a new object in the heap memory, even if the same text already exists in the pool. Therefore, comparing with this new string using equals return false, even though both strings contain the same text. Okay, string a, if you want to compare the string a that we had hello and then we created another string using new string hello, then comparing with a with this new string using equals, it will return false, even though both strings contain the same text. For this reason, using new string is generally unnecessary and it wastes memory. Another situation that can be confusing involves string concatenation with variables, right? For example, string text1 equal to good and string text2 equal to text1 plus morning. What will happen? Since text1 is a variable, Java cannot determine the result at compile time. Instead, it performs the concatenation at runtime, typically using a string builder, and creates a new string object in the heap. Because this new object is now stored in the string pool, comparing it with another string using equals will return false, even if the text is identical. To compare actual contents of strings, you should use dot equals method, which checks whether the characters inside the strings are the same. Now we are going to discuss compile time constant concatenation, the advanced trap. So this is a more advanced variation of the string pool concept that we discussed and that often appears in exam questions. When you concatenate two final string variables that are initialized with literals at the time of declaration, Java compiler knows their values during compilation. For example, final string w1 equal to good and final string w2 equal to morning. String result is equal to w1 plus w2. Because the values are known in advance, the compiler performs the concatenation at compile time and replaces with a constant good morning directly in the bytecode. Since the result is a compile time constant and it is also placed in the string pool, therefore comparing with another pool string using equals will return true. However, consider a slightly different case. Final string x, then x is equal to good, then string r2 is equal to x plus morning. Like we discussed, here the variable is declared as final, but its value is assigned later, not at the point of declaration. This means the value is determined at runtime, not at compile time. As a result, when this variable is used in concatenation, Java creates a new string object on the heap rather than using the string pool. In this situation, using equals to compare with a pool string will return false. The key rule to remember is final literal assigned at declaration is next is compile time constant, next full string. Okay, blank final assign letter leads to runtime value new heap object. Okay, then exam questions often present both scenarios and ask whether the equals comparison it evaluates to true or false. Okay. Now integer cache trap. We discussed the integer cache in the wrapper classes section, but it is important to revisit it when talking about equality comparisons. When Java auto-boxes an int to an integer, it uses an internal cache for values between -128 and 127 plus 127. That means that if you write integer a is equal to 127 and integer b is equal to 127, both variables will reference the same cached object. However, and therefore a equals b will evaluate to true. However, numbers outside this range are not cached. For example, integer a equal to 128 and integer b is equal to 128 will create two separate integer objects. Even though both objects contain the value 128, the comparison a equals b returns false because the references are different. There is another important case to remember. If you explicitly create an object using new integer 127, Java always creates a new object regardless of the cache range. This bypasses the integer cache entirely, so comparing it with equals will return false even for values within the cached range. The key takeaway is that using equals with wrapper objects can lead to confusing results because the outcome depends on how the objects were created and whether the value falls within the cached range. To avoid these issues, it is safer to use dot equals, much safer, which compares the actual values rather than the object references. Comparing with null using equals is also completely safe. However, for example, s equals null correctly returns true when the variable s is null. Even null equals null also evaluates to true because both references represent the same null value. However, calling dot equals on a null reference is very dangerous. If you write s dot equals hello and s is null, then Java will throw a null pointer exception because there is no object on which the method can be executed, right? If you write s dot equals hello and s is null, Java throws a null pointer exception because there is no object on which the method can be executed. To avoid this problem, a common safe practice is to place the string literal on the left side of the comparison. For example, hello dot equals, in this case dot equals is called on the string literal, which is never null. If s happens to be null, the method simply returns false instead of throwing an exception. This pattern is widely used as a defensive coding technique in professional Java code. Let's come to the practice question. So we have a equals b, same pool literal, true. A equals c, new string bypasses the pool, so it's false. Then a equals d, d is the same reference as a, so it's true. A equals c, same content, so true. So answer is a, true, false, true, true. Okay, that's about it in this video.